Okay, so question 14, 2016, let's have a look at this functions question. So the function h of x below gives the approximate height of the water at Hoth Harbour, picture of it here, on a particular day from 12 noon to 5 p.m. From 12 noon to 5 p.m. h of x is equal to 10x squared minus 50x plus 130, where h of x is the height of the water in centimetres, and x is the time in hours after 12 noon. Okay, so this is 12 o'clock to 5 p.m., 1 p.m., 2 p.m., up to 5 p.m. Okay, draw the graph of the function h of x is equal to 10x squared minus 50x plus 30. On the axis below, this is our domain, x is between 0 and 5. Okay, so if I was to draw that, this is what I would do if I was doing my junior cert. So I would draw out the table to show the examiner that I knew it was going to be a table format. They are my x values, and this tells you what your x values should be. So they start at 0, they stop at 5, and then it's up to you to decide what step size you go up in, okay? Normally it's ones, okay? And especially if it's only between 0 and 5, you're definitely going to go up in ones. You tend to write your function in here, h of x is equal to 10x squared minus 50x plus 130. And then out here, I have my y values, my h of x values, or my y values, whichever you want to call them. Okay, and what I tend to do then is just fill in one number manually. So what this means is x takes on the value 0 for this line. So anywhere you see x in the function, in goes 0. So that you end up with 10 times 0 squared minus 50 times 0 plus 130. Okay, in the next line, x takes on the value 1. So anywhere there was 1 in that functions, it takes on the value of, anywhere there was x in that function, it takes on the value of 1. And you can see these constants, which are just the numbers, they're fixed, they don't change, they stay where they are. Okay, and of course 2 in this line, x becomes 3 in this line, x becomes 4 in this line, and x becomes 5 in this line. Okay, but what I'll do is I'll put it into my calculator. Okay, so I'm hitting, to put this into my calculator, I'm hitting mode setup, and I'm hitting option 3 for table. Okay, and you can see you have the flashing FX symbol. Okay, so into that then you put in 10. Okay, how do we get at x? Well, x is big red X, I call it. It sits behind the bracket function. Do you see that? Just above the button 9 is your bracket, and hidden behind that is a red X. So you have to hit alpha. You see up in the top left, you have to hit alpha and that bracket, and you should get this big red X here. Okay, and I only call it red X because you have to hit the alpha button, which is red. Okay, so 10x, then hit squared. So hit the x squared button to get your squared. Put in minus 50 next, red X again, and then plus 130. Then you're hitting the equals to button. And what that equals to button does is it programs this into the memory of the calculator. So that's fixed in the memory of the calculator now, okay? So the next thing it asks you is start, question mark. So it's like, what number do you want to start your x's at? And we'd like to start them at 0, you see over here in our table. So hit equal 0 equals. Okay, the next thing we get asked is what number do we want to end our x's at? We'd like to end them at 5, see here in our table. So put in the number 5 equals. Okay, it then asks you what step size do you want to go up in between your x values, and we'd like to go up in steps of 1. So 1 equals. And then you get a table. Okay, you get a table that looks like, let me rub out the steps here now, they're all in the recording anyway, so they're there forever. You get a table that looks like this. And you have numbers down the side. You have x at the top and you have f of x across here. Okay, and then you have these numbers 1, 2, 3, 4, 5, 6 down the side. Okay, I would say ignore these values. That just means row data, data row 1, data row 2, data row 3, data row 5, 4 and 5 and so on. So ignore them, okay? They'll confuse you. So just look at these two columns here. One of them should be your x values, as in 0, 1, 2, and if 3, 4, 5, and 5, yeah, we stopped at 5. And you'll have to hit the replay button, so that big circle button in the middle, hit the down arrow there to bring down and see 3, 4, 5. Okay, but across from that, you should have 130, 90, 70, 90, 130. Did I miss one? 130, 90, 70. I did. I missed a 70, didn't I? Okay, so these are your y values. Remember I said in the last question we did y was the same as f of x, okay? So when x is 0, the answer I'm going to get is 130. So if you put that into your calculator like that, you'll get the answer 130. If you put this into the calculator, you'll get the answer 90. So your calculator gives you the answers to these when you write them in. So 70, 70, 90 and 130. Okay, so if I was presenting my work for an exam, for a test or an exam, this is exactly what I would do. I would produce this table here to show them I knew where the values comes from for a graph. And then these are your couples. So 0, 130 is my first couple. So 0 up to 130. So let's plot him. My next one is 1 and 90. My next one is 2 and 70. 3 and 70. 4 and 90. And 5 and 130. Okay, now when you're drawing this, okay, so it's going to be a quadratic, and we knew that because it was an x squared, an x and a number, okay, x squared plus bx plus c. So we're not surprised to see a smiley face popping out there. Just be careful. You see the 2 points that are at the same level, okay? So don't draw your graph like this. See, square at the bottom or flat at the bottom, because that's not how a quadratic looks. So the graph dips down and goes back up again. Okay, let me just zoom in on that. So the graph dips down and goes back up again. That's how you do 2 points that are at the same level. Okay, you have got to know that it dips between them. Or of course, if the graph was going the other way, it would rise between them. Okay, so you lose marks if you drew it like that. So with a nice smooth hand, or as smooth as you can, or as natural as you can, just join the dots. Okay, and as always, label your graph. Okay, so the questions then says, use your graph to find the height of the water at 12 noon. Okay, so at 12 noon, see the way I'm dotting up on my graph until I hit my actual graph. The height of the water is 130, and I'm looking for units. I'm reading here for units. H is the height of the water in centimeters. Okay, so 130 centimeters. Estimate the height of the water at its lowest point. Okay. Well, this is time, this is height. So its lowest point is here. Okay, so let's estimate that. So From the bottom of that graph, go across, and I make that to be about 63 centimeters, something like that. And that's why that word estimate is there, because everyone's will be slightly different. You're reading it from your graph. These construction lines as I'm drawing in, that's what you get the marks for in these questions. You have to have these marks on your graph to show how you're reading off the values. So they are super important. After 12 noon, how long did it take before the water was at its lowest point? Okay, so now it wants the time for when the water is at its lowest point. Okay, so that's its lowest point. Let's come down to time, to the time axis, and look, it's halfway between 2 and 3. So we would say 2:30 p.m. Okay, but it's these construction marks that are super important. And some students draw an arrow on them like that to show which way you're reading. Okay, and that's fine too, whatever you want to do. But some way or other, you're showing how you're getting these values that you read off. Because you can see there's no computation, there's no adding, subtracting, multiplying in these type of questions. So their theory, or I suppose the skill that they're examining is, can you read from a graph? Okay. Right, the next question then says, this part then was quite hard, I thought. So the graph on the right shows the approximate height of the water in centimetres at Crookhaven, so a different place on a different day from again 12 noon to 6 p.m. The graph is symmetrical. On this day, the height of the water at 12 noon was 180 centimetres, and the height of the water at the lowest point on the graph was 0 centimetres. Taking x as the time in hours after 12 noon. So x is the time in hours after 12 noon. This graph is given by the function ax squared plus bx plus c. Yes, because it's a quadratic, so you can write it as its general form, where a, b, and c are integers and x is an element of r. And then it says find the value of c. This value of c that is in a quadratic. Okay, so if we're going to find that value of c, we would like him to disappear, and we would like that term to disappear. Okay, and then we can solve that equation for c. Okay, so how do we do that? What could we sub in for x to make these cancel? Okay, well, the most easiest one to sub in for x is when x is 0. Okay, so remember, x is the time in hours after 12 noon. So this is x is 0, this is x is 6. Remember, it was said symmetrical. So write down the center of this graph is x being equal to 3, okay, because it's fully symmetrical. So when x is 0, I'll sub in 0 for them, and they'll cancel, and I should be able to solve for c. Okay, so let's sub in for when x is 0. Then I get g of x is equal to a times 0 squared plus b times 0 plus c. And what value was g of x when x was 0? Go up until you hit your graph, and you can see it was 180. Okay, so this cancels. This cancels. So therefore you're left with c being equal to 180. Okay, hence or otherwise, find the value of a and the value of b. So I have to find the other letters in this. Okay, so to do that, I need to sub in 2 more points and set up equations for a and b. So what will happen here is that you'll end up with a set of simultaneous equations. I only know that through practice of doing maths, okay? But when you've 2 unknowns, always think simultaneous equations. So we've used that point on the graph, okay, this one here. What other 2 points could we read off this graph? Okay, let me zoom in at it. Well, this point here is an easy enough one to read off. It is 6, 180. Just make that a little bit, it's quite thick. 6, 180. And the other point I would use is this point down here, which is 3, 0. Okay, now in theory, you can use any points along the curve of a graph, any points. And if you sub in 2 points like we're going to do now and solve simultaneously, you'll find the actual function. Okay, the function just like this one that describes the curve. Okay, so let's do it. So I'm going to take that first point, 3, 0. Okay, so again, this is x and this is y, okay? So in other words, I'm going to sub it into a times 3 squared plus b times 3 plus I now know what c is. So I'm going to put that in and it's equal to 0. Why is it equal to 0? Because the graph, my function, was 0 when x was 3. Okay, so sub in the x value for x and let it equal to whatever is g of x at that point. Okay, so let's work it out. So 3 squared is 9a plus 3b plus 180 equals 0. I'm going to bring the 180 over this side so that I have the letters equal to the numbers, and there's my first simultaneous equation. And I have to leave it there for now because I need another simultaneous equation to be able to solve it. Okay, so the next point I'm going to look at is that 6, 180 that was here. And again, x comma y. So I'm going to say a times 6 squared plus b times 6 plus c, which was 180, is equal to 180. So this 180 is c, ax squared plus bx plus c. This 180 is this y value. It's the value that the graph was when x was 6. So let's work it out. 6 6s are 36, so that's 36a plus 6b plus 180 equals 180. So I'm going to bring him over this side. 36a plus 6b equals 180 minus 180. Or of course you can subtract 180 from either side. 36a plus 6b is equal to 0. So that's my second simultaneous equation. So now I'm going to bring the two equations together. So 9a plus 3b is equal to minus 180. And 36a plus 6b is equal to 0. Whether I cancel the a's or the b's doesn't matter at all. Let's cancel the b's for no reason. So I'll do that by multiplying the top row by 2. I'm going to bring him up to 6b, and then I'll have 6b and 6b. I'll have to change the signs to cancel the 6b's to 0. Okay, I'm thinking if I cancel the b's to 0, I can then solve the a's. That's where I'm going with this. Okay, so let's multiply across by 2. 2 9s are 18a plus 6b equals minus 180. Leave the bottom one alone for now. Okay, we need to change the signs because if I add them at this moment in time, I get plus 6b is 12b, so they don't cancel, and I need them to cancel to 0. So to cancel to 0, I need one plus and I need the other one to be a minus. Okay, does it matter which row I change? No, not at all. I'm going to change the top row. So that plus is becoming a minus. This plus is becoming a minus. And this minus is becoming a plus. Okay, so then let's add. So I have 36a minus 18a is 18a. 6b minus 6b cancels. 0 plus 180 is 180. Divide by the number in front of the letter. So A is equal to 10. Okay, so I now know that A is equal to 10. So to find B then, I go back to either one of my equations, 1 or 2, and I sub in with my A being equal to 10. Okay, so I'm going to go back to whichever one looks easier. I think this one looks a bit easier. 36A plus 6B being equal to 0. So I have 36 times 10 plus 6B being equal to 0. 360 plus 6B is equal to 0. 6B is equal to minus 360. Bring numbers to one side. Divide by the number in front of that. And I'm getting minus 60 for B. Okay. So therefore, to describe my function then, remember my g of x was equal to ax squared plus bx plus c. My a is 10. So I have 10x squared. My b is minus 60. So minus 60x, and we had already found out that c was 180. So that describes that function. So it's a backwards question. They gave us the function in this part. They gave us 3 points on it, and you were to come up with the function. Whereas in other questions, they give you the function and you're to come up with the graph. Okay, so this was the more backwards type question.